Well, recently I came across a remarkable development in the field of large language models called Ouro, which was released by Bytedance SID team in collaboration with several research groups. What really struck me is that Ouro tries to teach a model to think during pre-training itself, rather than deferring reasoning to a later stage. In other words, the team designed a new architecture, a looped language model that iteratively refines its internal representation across multiple latent steps. So the model performs a kind of internal reasoning as it learns from raw data. To explain more concretely, traditional large language models usually learn to predict next tokens and only acquire complex reasoning ability through downstream fine tuning or clever prompting methods like chain of thoughts. Ouro's idea is different. During pre-training, it repeatedly applies the same parameter stack for several cycles, updating hidden variables each time. This looping process is like giving the model several chances to re-examine and refine its thoughts about the same input. Importantly, the model also learns an adaptive exit mechanism for straightforward input. It can stop early to save computation, while for complex problems, it will continue iterating. The designers even introduced an entropy regularization term so the model learns to distribute computation dips in a purposeful way. I found several aspects impressive. First, the efficiency gains are striking. The experiments in the paper show that relatively small Ouro models, for example with 1.4 billion or 4.6 billion parameters, can match, even exceed the performance of much larger conventional transformers on many benchmarks. This suggests that iterative latent reasoning can be a more parameter efficient way to scale reasoning ability, which is especially valuable when computational resources or training data are limited. Second, the term trained on a huge corpus. They report a multi-stage process totaling trillions of tokens. But the key improvements appear to stem from better knowledge, manipulation, and reasoning, not merely from storing more facts. In short, Ouro is not just a bigger memory, it's a smarter way to use the memory. Another thing that impressed me was the model's biological plausibility. The authors argue that the latent iterative refinement resembles human reasoning more closely than superficial chain of thought text generation. Instead of forcing the model to produce explicit intermediate text as a proxy for reasoning, Ouro performs those intermediate steps inside its latent space that seems more elegant and potentially more robust because it avoids exposing noisy intermediate outputs and focus on refining internal representation that feed the final answer. Also, the adaptive exit gate remind me of how humans sometimes stop thinking further once we are confident, but dig deeper when a problem looks hard. It's a neat computational analog of the behavior. From an application perspective, this approach could be transformative if smaller models can reason as well as much larger ones. Then services that need on-device or low-latency inference could benefit immensely. Imagine mobile assistants performing complex reasoning without having to query enormous cloud models, or specialized scientific tools that can reason deeply while remaining lightweight. There are also potential safety benefits. The authors reported that increasing the number of latent iterations can reduce harmful outputs on certain benchmarks, perhaps because iterative refinement enforces consistency and rejects spurious initial guesses. That said, of course, we could be cautious. New architectures bring new failure modes and require careful evaluation across diverse real-world scenarios. Personally, reading about Ouro made me excited because it felt like a conceptual step forward rather than an incremental tweak. The idea of treating parameter count for iterative computation, decoupling model tips from sheer parameter number opens a different access for scaling intelligence. It also reshapes how we think about pre-training. Instead of treating pre-training as merely a language modeling crawl, we can break in mechanisms that learn to reason. For someone who is interested in AI research and practical deployment, that's an inspiring direction because it promises both efficiency and more human-like reasoning patterns. To sum up, Ouro impressed me not only because it delivers strong empirical gains, but also because it proposes a new paradigm. Internal looped reasoning learned during pre-training combined with adaptive computation. If this line of work continues to mature, it could change how we design models for real-world tasks, where reasoning, efficiency, and safety all matter. That combination is rare and, in my view, worth paying attention to.